Okay, this video is giving you a visual of something you're going to do next year with Miss Bajeric. Okay, this is called the Pythagorean Theorem. And I want you to just use pictures to kind of understand this idea. And then Miss Bajeric will go into a lot more detail with what this is all about. Okay, but before we look at just the general idea, I do need you to know that the square root could be thought of as the edge of a square. Okay, so for example, if I have a square of 1, the square root could be thought of as the edge. See how all 4 edges are an edge of 1 space? Okay, let's see if I can make this go to 9. Okay, good. If I have an area of 9, okay, the bottom edge or an edge of the square is 3. Okay, so I could say the square root of 9, okay, the square root of a square of 9, that's 9. The bottom edge or any edge is 3. And let's look at 49. Okay, here's 49. Okay, the square root of 49 is the bottom edge of the square because there's 7 spaces right here. Okay, so just a nice little visual thing to think about. Okay, the square root could be thought of as an edge of its square. Okay, and the big idea with the Pythagorean theorem, they call it. Okay, we're going to be working with right triangles. Okay, a right triangle has a right angle. Okay, if you take any right triangle, okay, if you want to play around with this website that you have a link of, if you take any right triangle and you look at all squares that would be attached to that right triangle, okay, I'm just imagining squares attached. If you add up the 2 small squares, the areas of the 2 small squares, you will always get the area of the big square. Okay, 16 plus 49 gives you 65. Okay, look at this right triangle. 16 plus 25 will give me 41. Okay, that idea is called the Pythagorean theorem. Okay, let's look at another one. 16 plus 9 gives me 25. Okay, so what the Pythagorean theorem says, at least visually, is that the squares of the 2 smaller sides of a right triangle will always add up to the area of the largest side. And by the way, if you get mixed up which one is the largest side is always across from the right angle. Okay, it's always the longest. Okay, let's just go through some problems. Okay, in this right triangle, I have a right triangle with sides 9 and 11. Okay, I want to find the missing side. So what I need to do is think about that the area of these 2 small squares will add up to the big square. Okay, I know this is the biggest square because it's across from the right angle. Okay, so I'm going to start just thinking about what I know about area of a square. Okay, this is a 9 by 9 square. Okay, I can find the area by taking 9 times 9. So it's 81. Okay, this is an 11 by 11 square. I can take length times width. I can take 11 times 11 to be 121. Okay. Now the Pythagorean theorem tells us that these 2 small squares add up to this big square. Okay, so this big square area, I could find it by taking 81 plus 121. Okay, what is that? 202, I believe. Okay, so we're almost done. These 2 small squares add up to the big square. So my big square is 202. Okay, now I just need to take one more step. I need to find an edge of that square. Okay, the edge of a square is the square root of the area. So if I find the square root of 202, I've got my answer. Okay, so I gave you a calculator link. Okay, I can then I can click on square root. I'm going to hide that. 202 . 202 . 202 . 202 . 202 . 202 . 202 . 202 . 202 . 202 . 202 . 202 . 202 . 202 . 202 . 202 . 202 . 202 . 202 . 202 . 202 . 202 . 202 . 202 . 202 . 202 . 202 . 202 . 202 . 202 . 202 . 202 . 202 . 202 . 202 . 202 . 202 . 202 . 202 . 202 . 202 . 202 . 202 . 202 . 202 . 202 . 202 . 202 . 202 . 202 . 202 . 202 . 202 . 202 . 202 . 202 . 202 . 202 . 202 . 202 . 202 . 202 . 202 . 202 . 202 . 202 . 202 . 202 . 202 . 202 . 202 . 202 . 202 . 202 . 202 . 202 . 2 Somehow I had an extra space there. 202. Okay, I'm going to round it to the 10th. Okay, I'm going to round that to 14.2. 14.2. Okay, so the missing side of this right triangle is approximately 14.2. Okay, so we use the idea that the two small squares add up to the big square. So we figured out the missing square, and then we square rooted to find the edge. Okay, let's do one more. Let's do one that's a little different. Okay, we have a right triangle. We have a side length of 8, a side length of 14. Okay, so I want to find all the squares first before I can find the missing side length. I want to find the question mark here, the missing side length. Okay, I'm going to take 8 times 8 to get the area of this square, 64. Okay, I'm going to take 14 times 14. Okay, 14 times 14. So I believe that's 196. This one's a little different. I need to find this missing square. Okay, remember we said the two small squares add up to the big square, right? Okay, in the last problem, we had the two small squares. Okay, we started with figuring that out first. Okay, but in this problem, we have a largest square. We have the largest square and one of the small squares. So if I know the two small squares add up to the big square, I don't want to add these together. Okay, I want to subtract them. Okay, so I want to take 196 minus 64. Okay, so I'm going to subtract them instead of add them. So 196 minus 64 is 132. Okay, so my final answer is finding an edge of this square. The edge of the square of 132 would be the square root. Okay, so I'm going to use my calculator. I'm going to do the square root, find the square root of 132. Okay, I'm going to round it to the 10th. I just like to round to the 10th. So it's either 11.4 or 11.5. Okay, remember 5 or above, give it a shove. Okay, that 8's 5 or above. So it's going to be 11.5. Okay, so the missing side length is approximately 11.5. Okay, ask me in class if you have any questions. Hopefully, if you're absent, this will at least get you started. But please just contact me if you have any problems with anything.